Good morning, afternoon, Math 2 crew. I'm working on 7.2, and I'm going to work out all the questions that are odd, starting on page 378. So let's go straight to it. Section is about factoring by grouping. So directions, factor each polynomial by grouping. So when we talk about groups, we're talking about grouping symbols, parentheses or brackets. So I'm going to take the first pair of terms and group them using my parentheses or brackets. And so negative 3, a to the third, my first group, plus my second group. Again, that's our goal. Group the terms in the polynomial. Now the second step is to find common factors, the greatest common factor within each of the groupings. If you have a negative sign in the first term, factor that out. So now I'm highlighting the coefficient and the variables. So my greatest common factor amongst the coefficients is negative 3. My least power amongst the variables is a squared. That is the GCF of the first group. So this first term here, a squared, a to the third, a is the remaining factor. Since I factored out a negative 3, the second term is now positive 3. Remember, check it. Negative 3 times positive 3 is negative 9. And of course the a squared is factored out. So all we're left with is 3. Plus, same rhythm, same style, same technique. Identify a coefficient and constant. Factor what they have in common. Looks like negative 6. Okay. And now again, analyze your statement. Is there anything in common amongst the first term and the second term? Yes, there is. The quantity a plus 3. Factor that. So that's now my GCF, greatest common factor between these two terms. What remains in the first term is negative 3a squared. What remains in the second term is negative 6. Writing that as a factor is negative 3a squared minus 6. Plus negative 6 is equivalent to saying minus 6. And this is the factored form of the given polynomial. Next question. Excuse me. Factor by grouping again. And so I will take this expression, and I think I'm going to rewrite it by rearranging this here, and I'm going to write this as minus 2s plus 2. That sometimes is very helpful when you do that. Okay, it makes things cleaner when you group. So I'll just cross that off. Okay. So my first group. My second group. Identify the GCF in the first grouping. Five. Well, and s squared, lowest power. And so, here's what I see. I notice when I factor out the negative 2, what remains is the s, and I factor in a negative 2 from a positive 2, you're left with negative 1. Again, check it. Negative 1 times negative 1 is positive 2, so it's got to be s minus 1. Are there common factors within these two new terms? Yes, s minus 1. So, factor that. And what remains is 5s squared plus negative 2, which is equivalent to, say, minus 2. All right, moving on. Next question. Keep up. Factor each polynomial, check your answers. Okay, so we've got to check our work here. No grouping necessary here. Just identify the lowest power, since the 8 and 7 have nothing in common. This would be a c, 8c plus 7. And if you check your work, this is my answer, checking your work involves just looking at the original expression and doing the reverse of factoring, which is distributive property. And verifying that you end up with the original polynomial. And it's true. You see that? So it checks out. Next question. Okay, so here it looks like the GCF of coefficients is going to be 3. And then the GCF amongst the variables is x. So this is 3x. So I'll factor out a 3x. It's going to be 5x to the 4th minus 6. Now let's check our work. Let's verify this is correct. So checking my work, I write the original expression in factored form and FOIL or distribute, see if it's accurate. So 3 times 5 is 15. X times x to the 4th is x to the 5th. And the last step shows that that's negative 18x. So it checks out. It is the original polynomial prior to factoring. Number 5. Directions are the same, right? Yep, same grouping of questions. Number 5. I'm not going to group. It's going to find the common factor amongst the coefficients. Looks like it's going to be 6. And the lowest power looks like it's going to be n, right? Alrighty, so factor form would be, first of all, greatest common factor is 6n. This becomes n to the 5th plus 3 n to the 3rd. And again, you factor out 6 from 18 and you're left with 3. Minus 4, right? Because 6 divides into 24 4 times. So that's my answer. Again, if you're going to check this mentally, and I'll check this mentally just by verifying. 6n multiplied by n to the 5th is 6n to the 6th. 6n multiplied by 3n squared is 18n to the 4th. There it is. 6n multiplied by negative 4 is negative 24n. There it is. So it checks out. Okay, next question. The ball is hit vertically into the air using a paddle at speed 32 feet per second. That's the velocity. So the expression negative 16t squared plus 32t gives the ball's height after t seconds. Factor this expression. And so we're being asked to factor this expression, which gives the height of the ball after t seconds. So let's factor this expression here. Not a problem. Write the original out. GCF amongst the coefficients looks like negative 16, right? And the greatest common factor amongst the variables is t, because t is the lowest power. Factoring out a negative 16t. Again, we always factor out that negative sign if it's the leading coefficient. It's negative. So the v coefficient is negative. Factor out that negative sign. And I think that's it. Let's double check. If you check your work, multiplying through negative 16t squared. Yep. Negative 16 times 2 times negative 2 is positive 32t. Checks out. Moving on. Halfway done. Factor this expression, number 9. Like this. Just leads us right to this first term and the second term. And the quantity m plus 5 is a common factor. So let's factor that. What remains is 3m plus 4. Look at the next question. Factor each polynomial by grouping. So we're required to group, so let's take the first two terms here. And I'm going to group these together. And the way I'm going to do it is I'm going to kind of cheat. Not going to rewrite it. I'm just going to squeeze in my parentheses. How's that? Yeah? Now let's factor the greatest common factor between 2 and 8 is 2. The greatest common variable is x squared. It's the lowest power. So 2x squared is the greatest common factor amongst the first grouping. This would be x plus 4. Here, same idea. 3 is the greatest common factor between 3 and 12. X plus 4. And there it is. Just by grouping and factoring, you see a common factor again. X plus 4. Factor that from each of the terms. Right, what's left? And that is the goal for this lesson. That's the essential question, which is how can we factor polynomials completely using grouping? And I just showed you. That's how we can factor polynomials using grouping. Right? Notice that the polynomials are also written in standard form. That's a big condition. All right, we're beyond the halfway point now. Great stuff. Again, we're going to group this again. So I'll write this quickly. Now it looks like to me that taking a look at this, I might see if I group it this way. I might want to rearrange my grouping because I'm thinking that it might not work. But let's try it. Maybe this grouping will work because you can group the terms in any order you want. So I'll group it in this way and see what happens. So 6 and 10 have a common factor of 2. D squared and D have a common factor of D. Here this becomes 5D minus 3. Check it. 2D times 5D, 10D squared. 2D times negative 3, minus 6D. Plus, let's factor out a 7 here. 7 goes into 35 5 times, that's 5D. 7 goes into 21 3 times, so it's minus 3. Again, check it. If you were to multiply through, 7 times 5 is 35D. 7 times 3 is 21. Checks out. Now let's look for our common factor amongst the terms. And this is it here. Factor that, and we end up with 5D minus 3. What remains is the 2D and the 7. That becomes your next factor. And that is my answer. Looking good. We keep moving. Again, factor by grouping. So, this one looks kind of daunting, so we'll just give it a shot. We're going to factor this through and see what happens here. So we'll group the first. We'll look at the second grouping. See if anything pans out here. So 5, b to the third. my greatest common factor, b to the fourth power minus 3. Oops, this wouldn't be 3 to the b fourth. B to the third, this would just be b, right? Yeah, because b to the fourth is here, so that's correct. Yeah, I fixed it. So slight error there, but I caught myself. Double checking. 5b to the third times b is 5b to the fourth. 5b to the third times 3 is negative 15b to the third. So it checks out. Plus 3 minus b. Now, this is the opposite of that factor. So there's something that we talked about. See if I remember it. Is there any way to rewrite this expression so that I can make it equivalent to b minus 3? And yes, there is. So what I do is I look at this expression, and this is what I remember. Here's my thought bubble, okay? This is my thought bubble. I remember that 3 minus b could be reordered as negative b plus 3, right? And remember that negative sign could be represented by negative 1. So that negative sign there could be negative 1 times b, right? And so at this point I said, oh yeah, let's factor the negative 1. And so this becomes b, right? Now, in order to have plus 3, you'd have to subtract 3, because when you multiply by a negative 1 across the set of parentheses, a negative times a negative is a positive, so it would become positive 3, see? That's got to be b minus 3. And so I rewrote this expression, 3 minus b, as negative 1 times b minus 3. So the left side of the expression remains the same. The right side becomes minus 1 times 3, b minus 3. Replace this expression with this. Could I squeeze in the plus sign plus negative 1? Yeah, you could. But remember, we said that when you are adding a negative, it's equivalent to subtracting. Factor the b minus 3. So here's our answer. Number 1, this is on the next page. I believe it's 380. Could be wrong, maybe 379. Directions. Write the correct answer. The area of a rug, which is shaped like a rectangle, is 4x squared plus 4x. And that's in square feet. Factor this polynomial to find the expression for the dimensions of the rug. When we talk about dimensions of a rug, that's a rectangle. What we're talking about is a rectangle with its length and width. The length and width are the dimensions, and that's what we're trying to find. And so we know the area of this rectangle is the length times the width. Right? And so now we're being told that 4x squared plus 4 is, in fact, the area of this rug. So we'll substitute the area here for the letter A. And we're asked to factor that. And we found that by multiplying length times width. So can we factor that? Absolutely. 4x is the greatest common factor. And that is the factored form of the area. Now the key here is this. 4x is the length of the shape, And the width of the shape is x plus 1. And so those would be our dimensions. So we could write that. We could say, oh, okay, since area is length times width, we know that the area is this. After factoring it, we could see now that the length is 4x and that the width is x plus 1. Kind of cool. Those are called dimensions of the right. Number 12 says the perimeter of a rhombus is 12x plus 28 feet. Factor this expression. Then find the length of one side if x equals 8. Hint: a rhombus is a parallelogram with 4 congruent sides. Oh, okay, we know this. So, a little bit of geometry in this question. I love it. And so, perimeter is the distance around an object. A rhombus is a 4-sided figure. And when we travel around this 4-sided figure and measure each side, this would be the perimeter, 12x plus 28. Now, they ask us to factor this expression. So, why not? Let's factor it, and then find the length of one side if x is 8. So, sure, why not? So the perimeter is 12x plus 28. We're measuring in feet. They ask us to factor this, so I will. 12, will that work? Let's see. 28 is 7 times 4, right? And, yeah, so I think it's going to be 4, the greatest common factor, yeah. All right, so this is the perimeter of the object, and then it says, hey, find the length of one side if x is 8. Well, here's the interesting part about this is it looks like it falls right into this expression. See this 4 times 3x plus 7? If you have 4 sides, and I'm going to sketch this best I can, trying to make a rhombus, but 4 times 3x plus 7, that's similar to saying that if this side was 3x plus 7, then all of them are 3x plus 7. These are called congruent tick marks. And so if you multiply that by 4, you end up with the perimeter. So you can see it. Every side is 3x plus 7. So 4 times 3x plus 7 would be the perimeter of the rhombus. And so by just looking at this expression here, with 3x plus 8, or 3x plus 7, that's going to give us the side length, right, of that one segment. So let's find it. So the one segment, so one side length, one side is going to equal 3x plus 7. And we know that x equals 8. So we substitute. So it's 24 plus 7, which is equal to 31 feet. Now, there's also the technique of taking the whole perimeter and dividing it by 4. Now it would be 8 times 12 plus 28, dividing that by 4, and you would get 31 feet. It's the same answer. So no mystery there. But a very interesting question, to say the least. I think so. Number 5 says, the section where rosemary grows is square and has an area of 4x square feet. So what I'm going to do is I'm going to add some congruent tick marks, something that we learn in geometry. That tells you that these sides with these 1 slash marks are called tick marks. You're saying that they're equal in length, congruent. And the area of that shape is 4x squared. So I'm also going to write that down. Okay. Then it says, what is the length of one side? Okay. what is the length of one side? Well, each of the sides must be equal in length, or congruent. And so what you're asking is, can you find the side length S, right, called side length S, such that when you take S times S, you get 4x squared. So that's essentially what you're saying. You're saying that the area of the shape is S squared, right? And so I know that the area is 4x squared. It's given right here, see it? Area of the square is 4x squared, so we substitute the area with 4x squared. And we know that that's going to be found by taking one side and multiplying it by itself, S times S, or S squared. And so solving this, we take the square root of each side. We've talked about this before, taking a square root. Okay. So, several ways of doing this. There's something called the factoring property of square roots, and what that means is if you have factors underneath a radical, you can break them up separately. Cancels. So 4 is 2. Radical x squared is x. And so my side length is 2x. Looks like a 5, I know, but it's S. So the answer is C. Definitely a different question. Makes you think. And the last question. We made it this far. Let's finish off strong. The parsley and sage sections each have an area of 1/2 3x squared minus 6x minus x plus 2. That's in square feet. Factor the expression. And what are the base and height of each triangular section? What is the base and height of each triangular section? Okay, so we can do this. So I just want to make sure that you understand what the question is asking. Does the parsley and sage sections each have an area of 1/2 the quantity 3x squared minus 6x minus x plus 2? So this has that area, that section there, right, has this given area. And so does the sage. They both do. They're equal triangles. They're the same size and shape. So that looks like it's the area of a triangle. We know that the area of a triangle, right, a right triangle that is always found by taking 1/2 the base times the height. That would be the area. So if you take a real good look at this question, you can see that this polynomial here, the 3x squared minus 6x minus x plus 2, that represents this amount, the product of the base and height. And if you factor the polynomial into two factors, you're essentially finding the base and the height, which is a great question. Okay, see how that works? You are finding the base and height when you factor this polynomial of your triangle. So let's do it. Okay? So I'm going to factor the expressions. I'll write that down. Now I jumped the gun a bit because I know what's going to happen. I'm going to group these together. Common factor here is 3x, greatest common factor. Check my work. 3x times x is 3x squared. 3x times negative 2 is negative 6x. Plus, watch here, a negative sign, that negative x. That essentially the same thing as negative 1 times x, right? So I'm going to factor that negative 1 out. This becomes x. Of course, the negative sign makes this minus 2. Why? That positive 2, adding 2, a negative times negative is a positive, so that's got to be minus 2. So now I see that my common factor is x minus 2. So I'll rewrite this here. Becomes x minus 2 times the quantity 3x plus negative 1, or 3x minus 1. And so you can see that this polynomial here, right, the polynomial 3x, and I'll color code it here, different color. This polynomial right here is found by taking the product of the base and the height, right? And I took that polynomial and I factored it and found this. And so what that means is that your base is x minus 2, your height is 3x minus 1, and that looks like this expression right here, C. 3x minus 1, x minus 2. Well, I hope you enjoyed the show. We covered a lot of material, and you should have, give or take 10 minutes, maybe 15 minutes of class remaining. And so what I'd like you to do is complete any other sections that you have not completed. Study this material. You never know, I might give you a pop quiz. And when I see you tomorrow, we will continue on to 7.3. And for those who are willing to go on and move ahead, which is smart, 7.3, we'll finish all the notes, and then we'll also work on all of the odd questions. So, like I always say, study hard and learn a lot. We'll see you soon. Bye-bye.